All right, the last lesson of this unit is what's called the applications of the sinusoidal function. The sinusoidal functions are actually supposed to model real-life situations. For example, if you've ever heard of the Bay of Fundy, it's world-renowned for having the highest tides in the entire world. In other words, if you picture a tide having a highest level and a lowest level, each day there's a high tide and a low tide, and it keeps making this sort of a pattern as time goes on. It's a sinusoidal function. Same with, for example, the time on a clock, right? The highest time is 12 o'clock and the lowest time, let's say, is, well, 0 o'clock, right? It goes from, say, 12:01 up to 12 and back down, and it keeps going like this throughout the day. Those are sinusoidal functions, so they model real-life situations. Okay, so let's read what it says here. The horizontal axis of a sinusoidal graph is often labeled in terms of pi. When sinusoidal graphs are used in applications, the horizontal axis usually represents time. This is important. And the axis can be labeled in whole numbers. There are many real-world events that are modeled by sinusoidal functions, like the ones I just mentioned. There are many others. Let's take a look at this one. A piston moves vertically in a cylinder. So if you are familiar with a motor, there's something called a piston. Okay, a piston is round, something like this, and it moves up and down, and that's what creates the power for a motor. This piston will be moving up and down, back and forth. Okay? Obviously, it's limited to how far up it can go and how far down it can go, and it's always going to be the same. This is going to be a sinusoidal function. Okay, it moves vertically in a cylinder starting from its minimum height, okay, and then it goes to its maximum height. Every 20 seconds, the piston repeats its cycle from minimum of 15, so let's put 15 as a minimum, so that's where it starts, and then it goes to a maximum height of 35, so let's put 35 and say it goes up to there, and then it's going to come back down to 15. And this is supposed to be a sinusoidal function. Okay, well, how long does it take to make one of these periods? It says that it is 20 seconds. Now, since we know that a sinusoidal function is perfectly symmetrical, if that's 20, I know this is 10. In fact, I can also figure out where 5 and 15 are, because there are 4 intervals. Okay, let's figure out where is this midline. Well, what is in the middle of 35 and 15? This is a space of 20, so it must go down 10 and up 10, meaning this is 25, this midline. Okay? So it says, determine a sinusoidal function that models the height. Okay, so here you have a graph, and if you want a function, how do you write the function? Well, you need to know what A, B, C, and D are. You can see that the midpoint is 25, and we've already figured out that the amplitude is 10. It goes up, down 10 from the midline. Okay, now it says in this case a sinusoidal function, so we only need to do sine or cos. I think it's probably easier to do cos in this case because we already have the sort of that high point. I already know that this phase shift is 10 units. So for the cos graph, there's a phase shift of 10. And we already know that the period is 20, so b is going to be 2 pi divided by 20. This is pi over 10. So there is my equation. Y equals 10 cosine pi over 10 theta minus 10 plus 25. That's the equation. Okay, so part A is done. Then it says use technology. Now, use technology, you are not going to get technology for a test. You could easily, now that you have that equation, put it into Desmos, and then we could figure out this answer. Okay, but instead, let's estimate this height using another method. All right, this is saying at 26 seconds, so here's 25, here's 26, what is the height of the piston? That's the question it's asking. Okay, now you could graph it and kind of get an estimate approximately what it would be, but there is another way. All right, the other way is to actually use this formula that we just created. Okay, because guess what we know? We know what theta is. We know what the variable is. It's 26. Okay, so y equals 10 cos. Now this is going to be 16 pi by 10 plus 25. 16 pi by 10, we want to take cos of that. So let's see if we can figure that out. I got to grab my calculator. And I'm going to go, by the way, should we be in radians or should we be in degrees? Well, because I see that pi there, I'm going to make sure my calculator's in radians. And my answer is, I got 34.96. That doesn't quite make sense. Let me see if that makes sense. I don't think so. What did I do wrong? Let me just put that back in. Let's try again. Yes, that's why I had it in degrees. Okay, that's the wrong answer. So how did I know that 34 was the wrong answer? Well, if you look at my graph, if I would have kept going like this, there's no way I would have been to 35 yet, because that's supposed to happen at 30. Okay, so I knew that I was closer to 25 here. So that looks like the right answer. Okay, I'm going to leave the last example. This example you can try on your own. Basically what you're going to do is you're going to get a whole bunch of points if you plot each of these points, and then you're going to do the same thing. You have a graph then, and you can find the ABCD. Okay? So we're at the end of this unit. Here is your homework. I've already assigned these two, but make sure that you've done them. Okay? You have the two textbook assignments, and then you should also check the review that I have posted. There is a cumulative review, excellent practice before your test. All right, there it is.